right, today I'm going to go over some review for the exam. And this is going to be one example of something that is reviewed for the exam. So as opposed to last time I gave this exact same question where only 2 people got it, how many people do you think got it this time?
Everyone.
No. Let's see. 0 for 1, 0 for 2, 1 for 1, or 1 for 3, 2 for 4. All right, so we're getting better. 3 for 5, 4 for 6, 4 for 7, 5 for 8, 6 for 9, 6 for 10. So let's say 60%. All right, so first of all, your name is solution. Your section is 002 or 2. Your student ID is 8675309. I guess your name would be Jenny then, wouldn't it? All right. Everybody know what that is? Google it, all right? Those of you who are older, here's the good question. Who sings that song? Tommy Two-Tone is correct. Ding, 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 ding. A trip to the prize closet. Woo! You don't want to brag about that one? Okay. By the way, the song is called 8675309. In the parenthesis, it's Jenny. Nothing to do with the Jenny of Forrest Gump.
Don't listen to it if you don't want to be humming all day.
I'm going to have to play that on the thing. All right. The important thing is, I said this is a D flip-flop. What does that mean? Edge triggered. Oh, and I said rising edge triggered, which means what? Q will change on the rising edge. And Q will change on the rising edge depending on the value of D, which means at this point, D is going to be what? 0. And it will be 0 until the next rising edge, in which it will be 1. I'm going to require for this one you don't know what it is. Say that again?
Like a dotted line on the left.
If you have anything that doesn't say 0, so as an example, if you had something like this, either or isn't defined, that would be very nice. If you had something like don't know, that's very nice. If you had something like that would be very nice. If you had something like that would not be very nice. I like this. Aww. But you know, you still have partial credit, so I don't know. That almost looks like a glitch. We talked about glitches, right? Okay. This is a problem I gave in a class about 7 years ago, so let's look at this. Our inputs are going to be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. You don't get any points for writing this, all right? Because by this time, you should know that inputs are always like that. That's the easy part, all right? Oh, that would be helpful, wouldn't it? So you're in state 0, 0. If your input is D0, what's going to be your next state? 1, 0. I'm just going to do states right now. I'm worried about outputs later. All right? If you're in state 0, 0 and your input is D, what do you get? 0, 1. All right? You're in state 0, 1. Where do you go? Doesn't matter what D is, you're going to 1, 1, correct? You're in state 1, 0. Where do you go? You go to 1, 1. Doesn't matter what D is. You're in state 1, 1. Where do you go? 0, 0. Just as a recap, when are you making these transitions? Rising edge of the clock. All right? Now, you're in state 0, 0. What is the output? 0. You're in state 0, 1. What's your output? 1. You're in state 1, 0. What's the output? You're in state 1, 1. What's the output? 1. So let's see. How do I score this? Let's see. Correct. I'll give you 2 points. You're correct here. 2 points. Incorrect here. 1 point. All right? And then basically, what do I say? Two points, and then 3 points. I'll leave it to my TA to give extra credit, or not extra credit, partial credit. So, does everybody here, is everybody going to get at least 1 point?
Yeah.
Yes, all right. Question in the back.
The last last quiz, you said either 0 or, undefined for the 1 point.
I said it should be undefined, but I'll be so happy if you get 0. Because only 2 people got it. And then I went through and only 2 people got it, right? So, and what else did I say on that? What else did I say in class? Say it again?
You may see this again.
You may see this again. What else did I say? It might be on the the midterm exam. And what else did I say? This should be undefined. And if I were to give it again, I expect that to be undefined. I bet you that's on video. You think it's on video there? You have no clue, okay. You've seen so many of these. But one thing I would like to do is, just for grins, design the circuit. This is not part of the quiz, but I want you to do it for practice. Why would I want you to do it for practice? It might be on a test. Turn to your neighbor and do it. We are back. So, yes, I did have some people say that they solved this problem completely, and let's look at something really quick. So when I said the design for this, and I'm just going to hold this up here for a little bit, what's the design? What's the first thing to keep in mind? I have what kind of parts? Combinational parts. So we have combinational parts. With an input of D, an output of X. We have 2 other things coming down, which go to the registers. How many registers? How many registers? How many flip-flops in the register? 2 flip-flops, right? Because we have 2 bits. We have our states, 1, 2, 3, 4 states. Remember, you need the number of flip-flops is equivalent to flip-flops equal so you want enough flip-flops to, let's see, that wouldn't be 2 to the states. This would be more like states. Let me get rid of that. States is equal to 2 to the number of flip-flops. Right? Yes, sir. Oh, yeah, that would be helpful if I did that. This would be N1 and N0. Coming back up here would be S0 and S1. So when we did this design, I said, yeah, it would be really good if you did K-maps, right? Well, I could already tell that the formula for x is equal to S0. That's easy. So that's just going to be a wire. If we look at the K-map for the remaining 2 inputs, if we have our inputs of S1, S0, D, and we look at, this is for N1, we have 1, 0, 1, 1. And then we have 1, 1, 0, 0. So, oops, I should use a different color. So it's going to be a 3-input OR gate.
Don't you mean N1 instead of S1?
So N1, for what? For this?
Yeah.
No, N1 is going to be whatever this is. So on this side is S1, on this is S0D. All right? So what do we have? We have S0 naught D naught. And then we have or S1 S0 naught. Or up here we have, it looks like, what's 1 here? S0 S1 naught. N0 looking at our truth table, S0D, S1, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. This is for N0. Looking back at our table up here, 0, 1, 1, 1, and then 1, 1, 0, 0. Just wanted to make sure that was right. So this is obviously something, this is obviously something, and then we could either circle this or this. I'm going to choose that. Which means N0 is going to be equal to, what is this one? S1 and S0 prime. Hey, that looks like the same thing up there. Oh, look, here's another one too that's the same. That is, this one is right here, it's the last one I did, that was S0, S1 prime. And then nothing here is working with D yet, is it? Oh, except for this one right here, in which it turns out to be S0D, S0 prime D. So here's the thing to note. That's the same. And this is the same. So we could borrow those two, or we could we could use those two when we do our final design. So let's take a look at what our final design would be. First of all, we already know that X, our output, is just going to be S0. So I'll just make that easy. We're going to have two OR gates, and I don't think I allocated enough space. Oh, that is just one ugly OR gate. I think that's even more ugly. And one thing we know for sure, I'm just going to draw this. We have two AND gates that are going to be shared. And then let's see, what's the other AND gate that we have? N1 is going to be down here. And then we have this one up here. And here's the thing is, to make things neat, you don't actually have to show all the wires going everywhere. For example, look what I'm going to do right here. I'm going to say S0 and D, and I'll put a bubble there too. And then this one down here is S0, I'll put a bubble there, and D, oh, this is, yeah, that's right. And then we're sharing right here, this is S1, S0 prime. And then this one is S0, S1 prime. Is it prime or is this?
It doesn't say prime.
Oh, I need to put that one in there, sorry. Okay, you got that? This is what I would expect on the midterm exam. Question?
Is there any way for the Boolean expression for N1 that you could XOR S1 and S0?
Oh yeah, you could do XORs too. If you're smart enough to do that, all the power to you. Yeah, I mean, I'll accept either.
Okay, so it would be S0 not D not or S1 XOR with S0?
Correct. If you notice that these are just an exclusive OR of S0 and S1.
Okay.
Right?
Yeah. Okay.
Now, is it exclusive OR or exclusive NOR? Let's look at this. And oh, this is the input to both of them. So we're looking at which thing here? Oh, either this or this, right? So one or the other. So I think it's exclusive OR. Oh yeah, so that's right. This could have been. So good point. This could have been an exclusive OR. Oh, come on, man. All right. You all got that? All right, so now that we have the other students leaving, let's tell you what's really on the exam. All right. I'll take your question first here up front. Oh, now he came back. Yeah, for those of you viewing this in video land, you know, you can always look at the video. Well, are we going to have the video up by tomorrow? You could be really nice and do it. All right. Question?
When it first came out, why did you not use gray code?
Why did I not do what?
Use gray code.
Gray code?
Yeah, where you only change one bit.
I don't want to go in there. I don't want to go into that. I'm having not enough people understanding just regular design without going into tricks like that, all right?
But you did the two came out differently. Got 0, 0, 0, 1, 1, 1, 1, 0 for the second one.
Well, I mean, you know, the one thing that is different is I could have chosen, for example, this along with this, right?
You mean the top came out with a 1, 0 and a 1, 1.
Yeah, that's what.
Oh, no, this is, that's how I did solve it anyhow, so sorry. All right, so yeah, that was a mistake in writing it, but not solving it. Yes, sir. Yep. Anything else for this problem? All right, this is where, since this is open for preparation for the midterm exam, go ahead and ask a question. Is something going to be on the test? Well, I've already covered what's on the test. Everything we've done so far. Oh, I like that. Oh, yeah. Yeah. So everything up through lab 4. Yeah, lab 4 is posted.
Oh, we haven't did it in lab 4.
Lab 4 is out there, yeah. Oh, well, up through lab 4, the quiz that we just did today, the notes that I've gone through, and the homework that we've had. So at least I haven't posted homework number 4 yet, or 5, so it'll be through homework 4. And I'm going to have some multiple choice and some long answer. I'll probably have, all right, here, let's see. Do you want more multiple choice?
Yes.
Wow, really?
As little as, I don't know. Maybe the
Wow, okay.
very little.
Susanna, you're not saying a word. What do you want? You're fine with either. Okay, she feels strongly both ways, all right? All right, let's take a quiz. How many of you would rather have more multiple choice than long answer? How many of you would rather have more long answer than multiple choice? How many of you don't care? How many of you are a weenie and can't vote anyway? All right. Yeah, well, you know. All right, so you had a question?
Multiplexers, we didn't seem to concentrate on that as much as finite-state machines and registers and such.
All right, multiplexers.
Lauren just put a video up on that.
Pardon me?
Lauren just put a video up on that last night
Lauren?
at like midnight.
Yeah. I know, but we didn't seem to focus on that quite as much.
She has a video on that?
Yeah.
Wow. That's,
Put it up, but I haven't watched it yet. Just put it up last night.
oh, how come I didn't get that? Because I'm supposed to get it all. Because I'm mean? Is that what it is? No, is it something she recorded, or is this something that she pointed off somewhere else?
It's hers, yeah.
Oh, wow. Oh, all the power. Did you do this for her? Oh, yeah, okay. Man, you're slipping, dude. I haven't checked my email since last night, so.
Yeah, it was kind of late.
All right, so I'm going through, I don't know what time this is. Oh, yeah, look at that. She's got something up there. I've created a video to explain the differences between latches and flip-flops, as well as example on how to use Muxes. I've done this since they were topics that seemed to confuse people the most. The video is mostly me talking, so break out your notepads if you want to have the info in written form. I do not claim these topics are or are not on the exam. Just a brief disclaimer. I'll have to look at that to see if I can put something like that on the exam. All right, so did I answer your question? Yeah, so the answer is, okay. I mean, did we have decoders and muxes on the last exam?
That was it was like the lecture right after.
Oh, okay. Yeah, I might have something on that.
If you go, can you like clarify those questions, please? I watched the lecture video about that last night, so like last night.
All right. Muxes. I was going to actually go over adders today, which would have helped you for the lab, but I guess I'm not going to do that, am I? Sir.
How much of lab 4 would be on the test?
I don't think much, to be honest with you.
So like if we read through what we have to do, would that be enough? Or do we actually have to put some?
Don't worry. Okay, don't worry about lab 4. All right. Gee. All right. Do you remember the multiplexer? What we said we would do? Yes. No. What was the truth table for the multiplexer? Do you remember what the truth table for the multiplexer was? Well, let's look at what it would look like. Okay, so you see what this is, right? Up on the screen? Yes? No? Yes? All right. So, remember that. Because I'm going to draw something on the, draw something on here. So, if we look at a multiplexer, let's look at the truth table. Now, how many inputs are there? There's 6 inputs, right? There's I3, I2, I1, I0. I did use 0 as the first number, right? Yes, I0. All right, remember this. So the whole idea is I0, I1, I2, I3, and then you also have S1 and S0, right? You have one single output, which is D. And here's the neat thing. If S0 is 0, 0, I really only care what I0 is, right? And that's the whole idea. So it says, take whatever I0 is and route it out to D. So in this case, I choose I0, so that'll be 0. But, you know, we've got all these other ones in between. So in this case, when S1 is 0, 0 and I1 is 1, then this would be 1. You can see how this would be a 32-line table. This is just a pain, right? That's just a lot of work. So I said, let's just make this really easy. So in this case, the output of D is going to be whatever I0 is. I1, I2, I3. So if S1 is 1, 1, whatever I3 the input is. So if it's 0, if I3 is 0, then D, the output, is going to be 0. So this is a really easy truth table. So all you have to do is just remember how it works. By the way, you get to have 2 sheets of cheat notes.
Front, back.
Pardon me?
Front, back.
Front and back, if you wish. Put your name on it. Nah, I'm not going to collect them. I don't want them. All right, did I answer the Mux question somebody had? Who had the Mux question to begin with? All right. So is the Mux question addressed?
So the question would be, design a circuit using a Mux. I don't know. That's right. Yeah. Well, how would the question be worded?
Okay, number one, have I written the test yet? No. How will I have you do this? I don't know. Oh, yeah. I'm going to make a really hard problem now on a multiplexer because you asked the question. I seriously don't know what I would do. I mean, I would have to think about this.
Can you go over how to make a survey of that, though? Can you do that?
I don't think I have enough time in 3 minutes. Let's put it this way. Have I gone over something previously? I talked about adders, right?
Yeah.
So what's the input for my adder? It was one thing or another thing or another thing or another thing, right?
It's normally just the 3 inputs, right?
Well, I mean, don't forget S1 and S0 define which one of these 4 things are you going to just pass through. That's literally all it is. Now, there is one more, and that is if I were to have an enable line, maybe I should add this on too. This assumes that my enable is like this, but if enable is 0, then that's going to be 0. That's an important thing to understand as well. I might, for example, show a circuit that has a multiplexer in it and say, how would I determine that I pass something through? So just understand how a multiplexer works. All right? That's probably the best thing to do. If I were to say, what am I going to concentrate in the long problems? What do you think it's going to be? Finite state machines, because that pretty much brings everything together that we've done in this class, right? Your Boolean algebra, your combinational logic, your sequential circuits, how you diagram, how you solve a problem. That's what I'm really going to be interested in. So you should at least expect to have 1 or 2 finite state machine type of problems on the exam. I mean, I gave you a good example right here, right? But I only gave half of it here. Remember, I asked the second half. Now, complete the design. So I would bet money that the smart studier would put the process of digital design. There was steps 1, 2A, 2B, blah, 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 all that stuff. Understand that. We're about done. I could probably answer one more question that takes 1 minute.
You said 2 sheets front and back.
2 sheets front and back, 8.5 by 11. No A1. No architecture D. Did you have a quick question?
Is that 4 by 2 Mux?
This is a 4 by 1 Mux. There are only 4 or any n by 1 Muxes anyhow. Well, I mean, it's they call it a 4 by 1 Mux. All right? That's it. See ya.